So this one says, find the acceleration needed to bring a particle moving with velocity 75 feet per second to stop in 5 seconds. Okay, so they are talking about a constant velocity in this question. Maybe you physics people might find it confusing if it didn't say that. But of course, if you picture the way that you could stop a particle in 5 seconds, right? You could hammer on the brakes in your car and then lightly, come off of them, or you could stop at the last second and screech the tires for the last 2 seconds. But in this case, they'll be applying a constant velocity to it. So one way you can think about this, which doesn't require a whole lot of calculus, is if you're going to do a constant acceleration. On 75 feet per second for 5 seconds, what do you end up with? How much velocity are you getting rid of? 75, yeah. And you have 5 seconds to do it. Yeah, if you don't know how, you can put it in a calculator. There's nothing embarrassing about that. Yeah, it's 15. So that means I'm going to end up with 15. Actually, just to be clear about this, it's going to be negative 15 feet per second squared of acceleration. But let me show you the explanation that ties the calculus back to this rather than just the common sense. I'd say A+ if you just use your common sense. But here's the other way you can think about this, right? Change in velocity is going to be your acceleration, right? So for us, if it's a constant velocity, it'll be some constant for that amount of time that we apply the acceleration. And of course, like every differential equation there, we're going to need to figure out what's the constant we started with. So that gives you this little differential equation to work with. And we actually know what the constant is because at time 0, it tells us we're 75 feet per second. So if then you were to separate your variables, integrate them, oh, sorry, I jumped the gun here. That's the problem. Just have to make my apologies. I put the constant in before we'd even integrated it, so somebody should have yelled at me there. So it's your fault, not mine. Okay, so velocity in this case is going to be the constant, this constant acceleration for the time plus c. And I know at time 0, I have 75. So that's how I know the constant is 75. So that would give you velocity of time is this here. And if I want to know what the acceleration is, I have 5 seconds to make the velocity equal to 0. Okay, and that's the ridiculous egghead way of trying to answer the same question. Okay, but whatever. We'll leave it at that and hope that you recognize the common sense way, but it is actually a differential equations question if you're really, really in the calculus zone.